Hi, Mr. Barnes. I'm here to do the video on factoring quadratics project. So, start off with problem number 1 is going to be using the x method. X squared minus 5x plus 6 is our first problem. So, to do the x method, the first thing that we need to do is we need to split up our equation here the way that my brain works. So we need to find a number that is going to multiply to 6 and also add to -5. So we do our calculations. This number is going to be -3 and 2. So in doing this, we have this x squared. So we need to split that into a binomial, which is going to be x and x here. So when we do that, we know that we need to have a 3 and a 2. Now it's a matter of figuring out what symbols to put in to get a +6 and a -5 if we were to put it back into this phrase or equation. So that's going to be a -3 and a -2. When we do FOIL, it's going to FOIL back into this. So that's how you know that you did it correctly. That is how you do problem 1 with X method. Problem 2 is going to be using the difference of squares. So let me write that out. Our equation is going to be 4x squared minus 25. Okay, so in order to do this, we can see here that this is squared by this 2 up here. And we also know that 25, if we were to square root it, would be 5. So it's probably a wise decision to use the difference of squares to solve this problem. So we take this, we're going to take 4x squared and 25, and we're going to square root each of those, okay? So we do that, we get a 2x and a 5. So we know what our square roots are. So after that, now we're going to do what we did at the top in a sense, and we are going to split that into binomials as such. So we rewrite our equation here. 4x squared minus 25 equals binomials 2x and 2x. Now you may be wondering what's going to go in the middle here. If we only have one number here, 5 and 5, because we only have this and this, how are we going to get this negative sign? Well, it's simply what we learned earlier, is one's going to be negative and one's going to be positive. And this is going to be the answer for this problem. And just to double check and make sure that your teacher knows what the answer is, go ahead and box it off because you feel like it. And we can do that for the top one as well. Problem number 3, we're going to be using greatest common factor to solve this equation. So I write this out. Problem 3 is going to be 3x squared minus 18x plus 12. Okay, so in order to do this, we need to find a greatest common factor of the number 6, 18, and 12. And we take these, and we know, just by basic math, that the greatest common factor is 6. So now that we have identified that, we're going to go ahead and we're going to factor out the greatest common factor. So to do that, we're going to put the 6 over here. If we remove the 6 from the 2x squared, we remove the 6 from the x squared, we're just left with x squared minus, take the 6, divide it out, 3x plus a 2, because 6 times 2 equals 12. Now we have this this rewritten equation where we can then solve it out. Now, if this written out equation looks kind of similar, then you'd be right, because it's very similar to what we did in number 1, which is what we're going to be doing now. So we have to figure out what number is going to multiply to 2 and add to -3, just like what we did up here at top. So this number is going to be, these numbers together are going to be -1 and -2. And that's the numbers that we're going to be using. So you say, well, what about this 6 here? Well, just leave that alone, because you've already factored that one out. That's just going to be dropped down into the answer that we're getting ready to write right now. So just like we have written out here, these two binomials, you put the 6 on the outside. Just pretend the 6 isn't there, but you got to write it anyway because it's lonely. Because 7, 8, 9, and now it doesn't have any friends left. So go ahead and write x minus 1 and x minus 2 from here and here. Add them in, and you get your answer. And that is how you do factoring with the greatest common factor. This next one is a little bit more complicated. It's factoring by grouping. So, problem number 4. 4y squared plus 4y minus 15. What I like to do to help myself, so I can keep all my numbers straight, is I like to go ahead and label my numbers or letters A, B, and C. So we have this first, A, B, C. That way I know what I need to multiply together. So with grouping, what you're going to do is you're going to take A times C to get the number for this. So we have 4 times -15, which we know is 60. Ignore these, by the way. And you're just focusing on the numbers at the moment. So we know that we need to find a number that's going to multiply to -60 and, as above, like over here, add to +4. So we have -60 and +4. So what number is that going to be? Is that going to be? When we go ahead and we put it in our calculator and figure it out, the numbers are going to be 10 and -6. Perfect. So now we're going to go ahead and we have this. So we're going to rewrite it in for the middle term while still keeping the y. So what's that going to look like? Simple as this. We're going to rewrite it. 4y squared. That doesn't change. That stays the same. Then we add the 10y and we subtract the 6y, adding this letter, this y, into each space here. And then go ahead and drop your -15 as well. Now what we're going to do is we have to group the terms and factor out the greatest common factor from each group, just like we did up here. So what's that going to look like? Well, if we take these and we go ahead and we take these groups and we factor each of them, we can take out a 2y from each, because we have 4 is divisible by 2, and 2 squared can be taken out as well. But we only have one y here. I'm sorry, y squared, not 2 squared. We only have one y here, so we have to go with the one that's the least. So that's why we can put out 2, because 10 is also divided by 2. We have 2y, and then now we have to put what's left in our parentheses for this first group, which is going to be a 2y as well, because 2y times 2y is 4y squared. And then we have to take out what's the remainder of this one, which is going to be a +5. And if we want to double check, 5 times 2y is going to be 10y, which is what we get up here. So perfect, we did that one correct. Now what we're going to go ahead and do is we're going to go ahead and solve this next one. So what number goes into -6 and -15? Well, we know that that's going to be -3. We can take out -3 for that. But because -6 has this y here, but 15 is just by itself, we can't take out the y. So all that we're going to have is this 3 on the outside with what we have left. So -3 divided by -6 is going to be a positive 2y. And then we look here, -15 and -3, what's going to be left? We have a positive 5. And right there. Now, we have to factor out the common binomial factor. So what's this going to look like? Well, here, if you notice, these two are actually the same thing. That's perfect, because that means that you did this part right so far. This is going to be one of our binomials. Now, whatever number is on the outside of here, not inside the parentheses, is going to be your other binomial. So if we rewrite this to get our answer, we'll have 2y minus 3. And in the other one, we'll have our 2y plus 5, like from right here. This is going to be our answer for the factored form. Problem number 5 is a bit more trickier. This one's going to be factoring when the constant term is negative. So for this one, which I might run out of paper, let's just see how this goes here. The problem is going to be x squared plus 5x minus 14. So to do this, I need a little bit more of a visual. So what I like to do is I like to label my numbers and like I did up here. So we're going to have x squared plus vx plus c. That way I can just better visualize when I go ahead and I solve my problem. So let's go ahead and first look at this right here. It's letter C. So we can see here that this is a negative sign. So we know this is negative, which indicates that the two numbers have to be opposite signs, which means one is positive and one is negative. Now in this term right here, we see that the number is positive. And since the sum of the two numbers is positive, the number with the larger absolute value must be positive. So when we go ahead and solve that, why don't we go ahead and list the factored pairs of the constant term, which we've chosen right here, is going to be C. So when we look at this, we're going to have, when we factor this, 14, there's two ones that come to my mind, is -1 and 14, and then -2 and 7. And we know these all equal -14. So now it's a matter of figuring out which of these two is going to equal +5, because we want whatever the two of these equals, the two groups for -14, we want them to equal the +5, or else the two numbers aren't going to be positive. So just based off of common sense, we know that -2 and 7 are going to equal +5. So these are the numbers that we're going to be using to find the factored form. Now that we have written out what numbers we're going to be using, we can go ahead and we can go back to the simpler stuff that we've been doing up above. So we take our, I'm just going to go ahead and rewrite here what we have so far. So we have a 2x, we have a -2, and a +7. My work gets messy, so I just need to rewrite for a visual. We're going to go ahead and we're going to split this into our binomials. So we have 2, there we go, -2, x -2, and x +7. And that is the quadratic expression that we have for that. So perfect. We can go ahead and we can square off this as our answer. If we wanted to, we can double check our work by foiling and seeing if it goes back to this, which when we do that, it is going to equal, because we have these two, multiply this together, get a -2x. +7x, -2x, which subtract to equal +5x. And then we have -2 times 7, which equals 14. We know that we have done this correctly. I had to move my paper a bit. So for problem number 6, we're going to be factoring a perfect square trinomial. So let me see if I can't squeeze this in raw here. The problem that we're going to be using is going to be x squared plus 8x plus 16. So first off, when we are doing this, we are going to want to see and check if the first and the last terms are perfect squares and what the square roots are. So if we take this, we know that this is going to go down to x, and this is going to go down to a 4 if we were to square root it, which we are. So perfect. Now we have to confirm this middle term right here. So if we were to take these two and multiply it by 2 and 4 and then x, would we get 8x? And basic math tells us yes, we would. So this is good. We can use this method. This is perfect. Great. And we love that. So now what we're going to do is we're going to go ahead and we're going to make the binomial that we have today. So since the middle term is positive, this middle term right here is positive, we know that our binomial is going to be positive. Another thing with this is that when we have an equation like this, once we solve it out, which you'll see here in a second, the binomials are going to be the same. And I'll show you what we can do if they are the same so that we don't have to write out as much. So if we go here, we have x, factor and look at everything else. We see it's going to be a positive 4x on this side. And then over here, it's going to be x plus 4. Those are binomials. But wait a second. Why did we write it out twice if the signs are the same? And you don't necessarily have to do that. An easier and less writing way that you can do it is just go ahead and combine those into square. And you will know that this is what it actually means. It's just less writing and it's faster. That way you can get to your next math problem and get to bed sooner because we really like sleeping in our beds. Anyway, number 7 is going to be our wonderful word problem. So in 2 seconds, the word problem is going to magically appear on my paper and you're going to be like, oh my gosh, she has superpowers. So watch this right. Ta-da! So our word problem reads, the Sweet Treats Ice Cream Shop's weekly profit. P can be modeled by the following equation, where X is the price in dollars of one ice cream cone. The boss wants to determine what price points result in a weekly profit of $0 by factoring the quadratic. By factoring, find the price at which the shop breaks even. So we see here listed, the problem goes ahead and it gives us the equation that we're going to be using, which is negative 3x squared plus 18x minus 15 equals 0. So now we have to find the break-even point. So we're going to go ahead and we're going to identify if there's any greatest common factors, and if so, we're going to go ahead and we're going to factor it out. So we know that negative 3, 18, and negative 15 have a greatest common factor of negative 3. So we're going to take the negative 3 out, and what we're left with here is x squared minus 6x plus 5 equals 0. So now we have to factor what we have now, which is a quadratic trinomial. And we need to find the two numbers that multiply to 5 and add to negative 6. And doing our basic math that we learned from up here in problem 1, we can identify that those numbers are going to be negative 1 and negative 5. So rewriting this, we have x is negative 1 and x negative 5 equal 0. So now we have to solve by setting each factor equal to 0. Oh my gosh. So x minus 1 equals 0, or x equals 1. Once we solve it out, move the x over here, left with that. That's how I got that, by the way. And then same thing over here, x equals 5. So now we see this. In conclusion, the ice cream shop, this is going to be long, so sorry, Mr. Barnes. Ice cream shop breaks even when, that's then, when the price of a, I'm just going to write cone, is $1 or $5. And at any of those two values, the shop can make a profit. And at any price outside this range, the shop is going to lose its money. So that's how you do problem 7. Thank you for sitting in for my lesson today. I hope I did a good job. Anyway, have a good night, Mr. Barnes.